Could it be that Mars, the desolate red planet, holds the secret to a vast hidden water reservoir? This question has been the driving force behind countless explorations and countless dreams of what lies beyond our home planet. But why water? Why Mars? And why does it matter so much? Water, the lifeblood of our planet, is a fundamental requirement for life as we know it. It's the magical ingredient that sets Earth apart from the rest of the cosmos. If we find water elsewhere, it's not just about quenching a cosmic thirst. It's about the possibility of life, about understanding our place in the universe, and about the potential for future space exploration. Mars, our neighboring red planet, is a tantalizing target in this quest. It's close enough for us to reach with our current technology. Its geological history suggests that it once had conditions similar to Earth. And most importantly, there's been a plethora of evidence suggesting that water, that vital ingredient, exists on Mars. The intrigue of water on Mars is not just a passing curiosity. It's a puzzle that could reshape our understanding of the cosmos. If water does exist on Mars, it could mean that life, at least in some form, might have existed there too. It could also mean that Mars could potentially support human life in the future. Imagine human colonies on Mars, no longer just the stuff of science fiction, but a tangible, achievable reality. But the mystery deepens. The water we're talking about isn't just a puddle or a lake. We're talking about a vast hidden reservoir, trapped within the deep rock layers of Mars. This revelation came from NASA's InSight lander, a mission designed to delve deep into the Martian soil and study its internal structure. The search for water on Mars has been a journey of epic proportions, filled with remarkable discoveries and tantalizing hints, and we're just beginning to scratch the surface. Join us as we unravel the top 10 discoveries of subterranean water on Mars. We begin our countdown with the Curiosity rover and its groundbreaking discovery. Launched by NASA in late 2011, the Curiosity rover embarked on a mission to Mars with the primary objective to explore the red planet's ability to host life, past or present. As part of this mission, Curiosity rover was also tasked with investigating the planet's geology and climate. A significant breakthrough came when the rover stumbled upon ancient stream beds, a clear indication that water once flowed on Mars's surface. But the revelations didn't stop there. The rover's advanced instruments also detected the presence of water-related minerals in the Martian soil, further confirming the existence of water in the planet's past. Imagine the implications of this finding. Water is a key ingredient for life as we know it. The discovery of these ancient stream beds and water-related minerals not only suggested that Mars could have supported microbial life billions of years ago, but also set the stage for more in-depth investigations into the planet's history. The Curiosity rover's findings provided a critical piece in the puzzle of Mars's geological history. It confirmed scientists' theories that Mars was once a warmer, wetter world, potentially brimming with life. And while the rover continues to roam and explore, its initial discoveries have already reshaped our understanding of Mars. This evidence of past water set the stage for future discoveries. So, as we delve further into the mysteries of Mars, let's keep in mind the important role of the Curiosity rover in unearthing the secrets of this intriguing planet. Our ninth discovery takes us to the polar ice caps of Mars. These icy wonders, visible even from Earth, have long fascinated researchers. The ice caps are a mix of water ice and dry ice, the solid form of carbon dioxide. But it's the water ice that's of particular interest to us. Through a series of orbital observations and lander missions, scientists have been able to confirm that beneath the thin layer of dry ice lies an enormous reservoir of water ice. This discovery was a game changer. It provided tangible, irrefutable evidence that water, one of the fundamental building blocks of life, exists on Mars. As we further analyze this ice, we can learn about Mars's climatic history. The layers of ice, much like the rings of a tree, can reveal the planet's past weather patterns and atmospheric conditions. These icy wonders hint at the possibility of a much wetter past. In the eighth spot, we have the Phoenix lander, a spacecraft with a critical mission. Now let's rewind back to the year 28, when the Phoenix lander set off on its epic journey to Mars. Its purpose? To investigate the history of water on the red planet and to check for potential habitats for life. Phoenix lander, unlike its predecessors, was equipped with a robotic arm that could dig up to 0.5 meters below the Martian surface. It was during one of these digs that Phoenix struck gold, or rather, ice. It uncovered a layer of water ice just beneath the surface, a layer that sublimated into thin air once exposed. This was a game changer. This discovery was more than just finding ice. It was about understanding Mars's history, its climate, and the possibility of life. It was about understanding our universe a little better. This discovery solidified the presence of water ice on Mars. Next up, the Mars Reconnaissance Orbiter takes us further into our journey. This spacecraft, launched by NASA in 2005, took a deeper dive into the Martian mystery. Its mission was to probe Mars from orbit, looking for evidence of water that might have once flowed on the planet's surface. And boy, did it deliver. This intrepid explorer found signs of flowing water on Mars, but not where we expected. Instead of ancient, dried-up riverbeds, the orbiter spotted dark, finger-like features that appeared on slopes during the warmest months. These features, called recurring slope linii, seemed to ebb and flow with the Martian seasons. Scientists puzzled over these findings. Could it be that Mars, a planet much colder and drier than Earth, still hosted liquid water in these fleeting moments? The answer, it seemed, was yes. Using an instrument called the Compact Reconnaissance Imaging Spectrometer for Mars, the orbiter detected hydrated minerals in these dark features, a telltale sign of liquid water. But this wasn't just any water. It was likely a briny solution, full of salts that lowered the freezing point, allowing it to remain liquid in the harsh Martian conditions. So while Mars might not have babbling brooks or serene lakes like we do on Earth, it does have its own unique form of water flow. This orbiter's findings added another layer to the complex water story of Mars. It reminded us that even on a seemingly barren planet, life's most vital ingredient can find a way to make its presence known. Halfway through our countdown is the Mars Express orbiter's significant detection. Launched in 2003, this spacecraft has been scrutinizing the red planet from the top down for nearly 2 decades. One of its groundbreaking discoveries was detecting water vapor in the Martian atmosphere. Let's dive into this for a moment. Water vapor, the gaseous state of water, is an essential part of the water cycle, the continuous movement of water on, above, and below the surface of the Earth. Now imagine this same cycle playing out on Mars. The Mars Express orbiter found that during the warmer seasons, the ice caps on Mars release water vapor that rises high into the atmosphere. This water vapor then gets transported around the planet, condensing into clouds and eventually falling back to the surface. This detection gave us a glimpse into the planet's current water cycle. It's fascinating to think about how Mars, seemingly barren and dry, is still experiencing this life-giving cycle. At number 5, we have the MAVEN spacecraft's insightful contribution. This orbiter, short for Mars Atmosphere and Volatile Evolution, has been circling the red planet since 2014, studying its upper atmosphere. One of MAVEN's key discoveries is the rate at which Mars is losing its water to space. Here's a fascinating fact. Mars is steadily losing its water at a rate of about 2 kilograms of water vapor every second. That's like draining an Olympic-sized swimming pool every week. This is happening because solar winds are stripping away the Martian atmosphere, including its water vapor. MAVEN's findings have provided a crucial piece of the puzzle in our understanding of Mars. It's given us insight into the planet's past, a time when Mars was potentially a wet world, similar to Earth. By understanding this transformation, we can piece together what might have happened to its climate over billions of years. MAVEN's insight helped us understand how Mars transformed from a wet planet to a dry one. Our 4th discovery comes from the Mars Odyssey, another spacecraft that added to the water puzzle. Launched in 2001, the Mars Odyssey orbiter played a crucial role in the quest for water on the red planet. Its gamma-ray spectrometer, a sensitive instrument designed to measure the elemental composition of Mars's surface, detected large amounts of hydrogen. Now you might be wondering, what does hydrogen have to do with water? Well, water, or H2O, contains 2 hydrogen atoms for every oxygen atom. So, detecting hydrogen is like finding a giant neon sign that screams, "Water was here." But in this case, the hydrogen indicated the presence of water ice beneath the Martian surface. Think of it like an enormous, icy reservoir locked away in the Martian soil. This evidence brought us closer to the reality of water on Mars, a reality that continues to captivate and mystify us today. In the 3rd spot, we have the Mars Global Surveyor's crucial contribution. The Mars Global Surveyor, or MGS for short, was one of our earlier Martian explorers, but its findings continue to shape our understanding of Mars' watery past. In the late 90s and early 2000s, the MGS was busy snapping thousands of images of the Martian surface. Among these photos, scientists noticed something intriguing: gullies and ravines that looked suspiciously like they were carved by flowing water. Imagine a dry riverbed here on Earth. Over time, the rushing water erodes the land, creating a distinct, winding pathway. That's what these Martian gullies looked like. But these weren't ancient, weathered features. They looked relatively fresh, suggesting that water might have flowed there not so long ago. And it wasn't just one or two gullies that the MGS found. It was hundreds of them, scattered across the Martian surface. Each one was a potential clue, a signpost pointing to Mars's wet history. But the MGS did more than just capture images. It also sent back data about Mars's gravity, topography, and magnetic field, all of which helped to build a more complete picture of the red planet. These findings pushed scientists to think differently about Mars. It wasn't just a dry, barren planet. It was a place that might once have been home to rivers, lakes, and maybe even oceans. These features pointed to the possibility of active water flow on Mars. Our second discovery takes us to the ExoMars Trace Gas Orbiter and its intriguing findings. This European Space Agency mission, in collaboration with Russia's Roscosmos, has been orbiting the red planet since 2016. Its main objective? To search for evidence of gases in Mars's atmosphere that could be related to geological or biological activity. One of its most profound discoveries so far is the detection of a subglacial lake on Mars, a finding that has stirred immense excitement among scientists and space enthusiasts alike. But why, you might ask? Well, where there's water, there's the possibility of life. This subglacial lake was found beneath the planet's southern ice cap, and it's not a small puddle we're talking about. Imagine a body of water spanning 20 kilometers, trapped under 1.5 kilometers of Martian ice. That's a lot of H2O, and it's not alone. Around the main lake, the ExoMars Trace Gas Orbiter has detected several smaller bodies of water, painting a picture of an intricate subglacial network. This discovery has implications for our understanding of Mars's past. It suggests that Mars, much like Earth, has had periods of water activity. It also hints at the possibility of a warmer, wetter Mars in the ancient past, so the ExoMars Trace Gas. Orbiter's findings have not only given us a glimpse of Mars's hidden water resources, but also a tantalizing hint of its potential habitability. This discovery took us a step closer to understanding the planet's water history. At the top of our list is the InSight lander's spectacular revelation. This discovery truly took the world by storm, as it unveiled something far beyond our wildest dreams: a vast underground water reservoir on Mars. This wasn't just a small pocket of moisture or a thin layer of frost. No, we're talking about a reservoir of considerable size, trapped deep within the Martian rock layers. This reservoir isn't just a simple pool of water. Oh no, it's like an intricate web, held captive within the planet's rocky skeleton. Imagine an underground labyrinth, its corridors filled not with air but with water. All this hidden beneath the red, dusty surface of Mars that we're so familiar with. The InSight lander, a robotic pioneer, was the one to uncover this secret. Its mission was to explore the deep interior of Mars, to understand the planet's crust, mantle, and core. But in doing so, it stumbled upon this underground treasure, a testament to the planet's aqueous past. This discovery is particularly fascinating because it offers invaluable clues about Mars's ancient climate. It suggests that once upon a time, Mars might have been a lot more similar to Earth than we think. It paints a picture of a planet that was once warm enough to sustain liquid water, a cornerstone of life as we know it. This reservoir also raises tantalizing questions about the possibility of life on Mars. Could there be organisms, however simple, thriving in this underground oasis? Could this be the Martian equivalent of Earth's deep-sea hydrothermal vents, teeming with extremophiles? The possibilities are as vast as the reservoir itself. Of course, these questions remain unanswered for now. But the InSight lander's discovery has undoubtedly opened a new chapter in our quest to understand Mars and indeed the universe. It has brought us one step closer to answering the age-old question: are we alone in the universe? This discovery not only topped our countdown, but also revolutionized our understanding of Mars. It's a tale of water, of life, of possibilities, and it's a tale that's only just begun. The discoveries of water on Mars have sparked a revolution in our understanding of the red planet. This treasure trove of information has vast implications, opening up exciting new possibilities. The presence of water, especially in subterranean reservoirs, hints at the potential for life, past or present. Water is a fundamental requirement for life as we know it, and this discovery fuels the tantalizing possibility that Mars, our neighbor, may harbor microbial life. Moreover, these findings are not just about life. They also have significant implications for future space exploration. Water can be split into hydrogen and oxygen, which can be used as rocket fuel. This could enable Mars to serve as a pit stop for deep space missions, revolutionizing our approach to space travel. As we continue to explore Mars, who knows what other secrets the red planet holds for us? Before we conclude our thrilling journey of Martian water exploration, we'd like to remind you that this is just the tip of the interstellar iceberg. There's so much more waiting to be explored, and we're thrilled to have you on board for this astronomical adventure. If you've enjoyed diving into the mysteries of Mars with us, do give this video a thumbs up and share it with your fellow space enthusiasts. We'd love to hear your thoughts on the potential for life on Mars in the comments section below. Do you think we're alone in the universe, or is there life hiding in the Martian soil? And if you haven't already, make sure you hit that subscribe button and ring the notification bell so you don't miss out on any future voyages into the cosmos. Remember, every share, like, and comment helps us bring more of these space mysteries to light. So keep exploring, keep questioning, and keep reaching for the stars. The universe is a big place, and we're excited to uncover its secrets with you.